In this video, I will be going over the section 9.4 Day 1 notes, and here we're going to be graphing ellipses. Now an ellipse is another type of conic section where if you take a cone and a plane and you slice that plane at an angle through the cone and you're not going through the base at all, you get this oval or elliptical shape. If I were to tilt that plane and make it parallel to the base, if I were to just tilt it slightly, then I would be getting a circle. Or if the bottom of this plane intersected actually with the base, then I kind of cut that off and I would just have part of that, which would be a parabola. But ellipses are important because there are a lot of different things in real life that use the shape of an ellipse. We have elliptical orbits being the most obvious example. And kind of a non-obvious example, just something pretty interesting if you've never heard of them before, a whispering chamber, where if you have two people who stand kind of in particular points in this room and they whisper, wherever they speak towards, whether they speak this way, or this way, all those whispers will bounce to another special point. And I bring up this diagram because these 2 points are the foci of the ellipse. And foci is just the plural form of focus. So in a parabola, we had a singular focus, but in an ellipse, we have 2. And in an ellipse, the set of all points, an ellipse is the set of all points in a plane such that the sum of the distance between P and 2 fixed points is a constant. So imagine this being the focus and this being the focus, and P is a random point on the ellipse. This plus this always has to be the same value, and that's just a definition, but an animation might show you this a little bit better. So imagine this being one distance and this one being the other. As that point moves around the ellipse, the sum must always be the same. So here's just a quick animation of that. So notice the red plus the blue is always this length right here. No matter what point you pick on the ellipse, the sum of the red and the blue distance is always the same, and that's how an ellipse is formed. And the key here is that instead of having a focus in the center, there is going to be 2 foci, one on each side of the center of the ellipse. So every ellipse has a center, and every ellipse has 2 foci, as we said here, but then there's a couple other important vocabulary terms. The part of the ellipse that holds the center and each focus, so this right here, or if my ellipse is more vertical, this right here, the line that holds the foci is called the major axis. And the endpoints of the major axis are called the vertices. The other part of the ellipse that does not have the foci, so either this one or this one, that is called the minor axis, and its endpoints are called the covertices. So the major axis will have a length. If you look carefully here, they denote a variable A, they denote a variable C, and then, B, and then they also denote a variable C, which is actually a little bit smaller than A. So if I start from one vertex and go to the other, the major axis has a length of 2A, whereas the minor axis has a length of 2B. So if I start in the center, the distance from the center to a vertex is just A, where the distance from the center to a covertex is just B. And if I double that, that's how I get each axis. Now the C value is the distance from the center to just a focus. So it's just this little part right here. So that is always going to be smaller than the A value. And so there's a relationship that you can use to help you find some of these missing values. Very important. We're going to be using that a lot today. But before you move on to what I'm about to talk about with the equations, maybe take a moment just to read through these 3 paragraphs, identify where these vocab words fall on the diagram, and just become a little bit more familiar with them before we move on. The biggest thing here is that A is going to have the largest length. Okay, it's going to be the longest. And then B and C just follow after that. So the equation of an ellipse, the standard equation of an ellipse, follows 2 different forms. And the big difference between these forms is if the major axis is horizontal, as we see in this first diagram. So this first picture goes here. Or if the major axis is more vertical, and it follows this diagram. And the only change in the actual standard equation is the a squared and the b squared values. They switch places. Okay? A is always going to be bigger, so one way that you can know if your ellipse is more horizontal than vertical is to find that a value. Since the a value is associated with the x, we say that this is a little bit more horizontal, whereas over here the a value is associated with y, so we say it's more vertical. But the biggest thing here is that it's always going to be equal to the number 1. So in a circle, it could have been any value. But in an ellipse, we always have this equal to 1. And once you know a little bit about the ellipse, and you can find some information using this equation here, you can actually write out the vertices or the co-vertices using this information down here. And so it's important to note that not only do we have these information here and this formula, but we also know this. And there's one other thing here. So the focal length is just the distance from one foci to the other. So then that would be 2c. Vertices always lie on the major axis, always. Same with the foci. Those kind of all fall along the major axis. But the co-vertices, those are the only thing important on your minor axis. So having that, let's go ahead and go to the back. So what I'm going to do is I'm going to graph this ellipse, and I'm going to identify the vertices, co-vertices, and the foci. But I'll also probably want to identify the center as well. So this is pretty plain Jane. If you look at x, it's by itself. If you look at y, it's by itself. So that one is going to have a center at 0, 0. Okay? So you can imagine we don't usually label this point because the center doesn't help us graph the ellipse, but I'll go ahead and put it there for the sake of the picture. Now I have to identify the a, the b, and the c terms before I can start answering the rest of this question. So a squared is 16, okay, so b squared then would be 9, and a squared is always the bigger number. Now, since a squared is under x, this is going to be more horizontal than vertical because the bigger number is underneath the x value. So that would make a equal 4, b equal 3, and then I go back to the front of the page and I use the equation c squared is equal to a squared minus b squared, which would be 16 minus 9, which would be 7. So then if you take the square root of 7, you get around plus or minus 2.6. Okay, so knowing this information, I've got the center, and I know that my major axis is going to be horizontal. I'm going to take that a value of 4, and I'm going to go 4 units to the right and 4 units to the left. And then I'm going to go up or down 2.6 units. All right, and just like my circles, I usually don't do such a great job drawing these, but the other thing that I want to list out are the foci, and so that would be 3 units and it's still going to be horizontal because the major axis is going to be going from left to right, 3 units in either direction. So right here and right here. So if I were to go through, I would list out the vertices. Those are at plus or minus 4, 0, whereas the co-vertices are at 0, plus or minus 3. And then the foci are at plus or minus 2.6, 0. All right, so this wasn't so bad because it was centered at the origin. When I move that center, these values, of course, are going to change, and it's probably a little bit easier to graph it first, then just kind of write down this information here. But the key is having this equal to 1. So if I look at problem number 2, in order to graph this ellipse, I have to divide everything by 36 so I can get it set equal to 1 on the right-hand side. So that would change it to this equation right here. It would be x plus 2 squared over 6 plus y minus 1 squared over 9 equals 1. So that's the standard form. And so a couple different things here. Because 9 is the bigger number between 6 and 9, and it's underneath the y value, this is going to be a more vertical ellipse. So a squared is going to be the 9, and b squared is going to be the 6. So then I know that a would equal 3, b would equal the square root of 6, which I think is around 2.4. And then the c value I would find using this equation here. So c squared is equal to a squared minus b squared. So that's 3. So then c is equal to the square root of 3, which is around 1.7. And of course, I could write plus or minus on those, just like I did up here. All right, so the other thing to note, the center of the ellipse Here we go. The center of the ellipse is -2, 1. So just like in a parabola, think about the opposites when you find that h and that k value. So I'm going to go ahead and plot the center at -2, 1. Now my major axis goes up and down. It's a vertical. So I'm going to take this a value, which is 3, and I'm going to go up 3 units. I'm going to go down 3 units. And so there's 2 different ways you can do the vertices. You can graph them first, and then just list out, hey, one of these vertices is the point -2, -2, and then the other point is the point -2, 4. So that's kind of the way that I think about it. I graph it first, and then I write the answers. Though, if you just wanted to do it as a formula, you would go over to the front side of your notes, and you would just plug in the values here. You know h, you know k, and then you can just do plus or minus a, and that can give you those exact same answers without necessarily graphing it. So those are listed there for that reason. And so then the co-vertices, and this is where those formulas might come in handy, those covert vertices are going to use the 2.4. So I can go 2.4 this way, or I can go 2.4 this way. And my ellipse looks like this. I still have to put the foci on there, but it looks a little bit like this. So to list out those co-vertices, that would be the h value plus or minus b, k. So the h value plus or minus the b value, k. So I don't want to leave it like that. I want to clean it up. But if you want to, instead of using the graph, because the graph here might not be as beneficial since I'm dealing with decimals, you might use the formula. I believe that comes out to be around -4.4, 1, and I'm going to run out of room here, 0.4, 1. Okay, I think that's what those two come out to be. And then the foci, you can do that in a very similar way. The foci can be found by just adding the c value to the k value. Okay, so this actually isn't listed on your table, but if you wanted to, it's going to look very similar to this. I'm just going to be adding c instead of the a value. And so if I were to add the table on the other side, it would look like this. So if you like these formulas, you might take a moment and add those to your table. Those are going to give you each focus. Okay? But now that I have that, I'm assuming that you would be able to find those 2 points, whether you use the graph or the formula that I just wrote down. But you would graph those. And then you would be done. Okay, so it might be better if I start boxing up some of this information, just because there's a lot of it here. So I'm finding the center, the 2 vertices, the 2 co-vertices, and the 2 foci. And really, really helpful having those equations here from the front of the notes. I've got a couple more here that we can talk about, but really I just want to do one more of these to give you another example. So number 3 is probably the next one here in order. So let's talk about number 3. In the previous problem, we had to divide by 36 because I needed it to be equal to 1. Here, this is not in any standard form, and I don't even see the parentheses being squared. So when you don't see the parentheses being squared, that's your indication to complete the square. So I'm going to rewrite this. I'm going to group the x's together. I'm going to group the y's together. And then I'm going to add the 159 to the other side because it doesn't have a variable. Now what I'm going to do is I'm going to try to complete the square with the x's and the y's. So the first thing I'm going to do is take out a 16 from the x values, and then I'm going to leave a space. Then I'm going to take out a 25 from the y values. So that's 6. Leave a little bit of space, and then I have 159. All right, when I complete the square, I take the b value, which is -2, I divide it by 2, which is 1, and then I square it, which is 1. But then I have to take 16 times that 1 to balance the equation. In the same manner, I'm going to take -6 divided by 2, that's -3. -3 squared is 9, but I have to take 25 times 9, which I believe is 225, and add that to the other side to keep it balanced. So then I get 16 times, and I'm going to factor this as x minus 1 squared, plus 25 times y minus 3 squared, equals a very large number. I believe that's 400. And then just like in the previous problem, I'm going to divide both sides by 400. And it's not going to leave me any room to do any extra work, but my standard equation would be x minus 1 squared over, that reduces down to 25, plus y minus 3 squared over, that's going to reduce down to 16, is equal to 1. So there's a couple different things you can pull away from the problem now. We know that since the bigger number is underneath x, that this is going to be more horizontal. We also know that the a squared value is 25, the b squared value is going to be 16, and so you can kind of use those two values just like we did up here to find the c value. But my center is going to be, let's see here, 1, 3. 1, 3. And so if you just wanted to go through and use the formulas to help you answer all of this stuff, we certainly can do that. So this is a horizontal ellipse, so I'm going to be using this side of the table right here. So if I wanted to find the vertices, I would take the h value plus or minus the a value, which would be 5, because that's a squared, comma, k. And of course, you would clean that up to get 2 points, and those 2 points would be 6, 3, and negative 4, 3. The covertices would be found, if I go back to my, this one is h, comma, k plus or minus b. H, comma, k plus or minus b. b would be 4. So then that would give us 1, comma, 7 and 1, comma, negative 1. That's right. Now, to get the foci, I have to find the c value. And remember, the c value follows this formula right here, which we wrote all the way up in problem number 1. So I have to take a squared minus b squared. So c squared would be 25 minus 16, which I believe is 9. So then c would be 3. So then I'll go to my table one more time, and I'll do this part that we wrote down. H plus or minus c, so h plus or minus 3, and then k. So then the foci should be 4, comma 3, and what, negative 2, comma 3? And that's without even graphing it. So I'm going to guess that a lot of you will probably follow that type of procedure and then graph it instead of doing the reverse. And that's just fine, especially on problems like number 2 when you have decimals. But what I'm going to do here is I'm going to go ahead and just kind of stop, because the other problem kind of follows the same suit. And I'll just kind of show you the work for these last 2 problems if you'd like to finish these notes. Okay, so this is the answer key to these. You can see the work for number 4, and then of course you can see the graph that I didn't complete for number 3. But feel free to pause the video, finish up whatever you need to finish here, and then reach out if you have any questions or concerns. But that's it for today.